When students first learned about functions in pre-calculus, calculus at the high school level, they're always using x as their variable. And then when they get to college or more advanced calculus and we start throwing at them other variables with other names, invariably, no pun intended, it blows their minds. They're not ready for this change. And it's such an important thing to consider what is the variable and what is constant with respect to that variable. And I love this post because it's exactly about that problem. So let me show you why this is technically correct. When we see something like this, we are going to immediately assume that that means derivative and that this is a function of the variable x, that k is going to be a constant, and therefore the derivative of this function is going to be k. Notation is very important, and it is important to use intuitive and natural notation that we're all used to because it makes reading math easier. But you always have to be precise and think about, like, is this really a derivative with respect to x? What if k was a variable and x was a constant? Then this would be wrong. That's why we use the ddx notation to tell us that that apostrophe, it is a derivative with respect to x. And here we are going to assume k is a constant or constant with respect to x. Therefore, the derivative of this product is just going to be k. But it could be the case that k is a variable, that x is a constant with respect to k, and therefore when we take the derivative of this function of k, the derivative will be just the constant that is in front of k, x. So what is happening here? What happened is that I've decided, a very terrible decision on my part, but I've decided to call my variable log, and therefore this is the derivative with respect to log of log x. Here there's supposed to be a dot because this is the variable log times x. So this is a linear function in log with a slope x, and therefore the derivative of this function of log is just x, the slope. My favorite expression of this sort is this one, where I've decided to call my variable d. So d of d equals 1. And, or in other words, if you cancel out all the d's, well, yeah, you get 1.